Okay, we are continuing on solving the non-homogeneous differential equations. Today we will talk about using the undetermined coefficients in order to solve a non-homogeneous differential equation. As we discussed in the previous lecture, non-homogeneous differential equations have a general form. That general form looks like y double prime plus p of x y prime plus q of x y equals certain function f of x. Okay, then we said in order to find the final solution for non-homogeneous equation, your solution will be two parts: homogeneous solution and non-homogeneous solution, or particular solution. So your final form will be something like y homogeneous plus y particular, just in order to simplify things. In order to simplify things, you start with y homogeneous. Now you start solution. Let's say equation number 1. Now you want to solve it as a homogeneous equation. What you will do, you will assume that this part equals 0. So we can say y double prime plus p of x y prime plus q of x multiplied by y equals 0. Then we can use either exponential guess method or any other method that has been explained in order to solve a homogeneous differential equation, and you will find your final solution. Now for the particular solution, yp, so you can see that yp equals whatever on the right hand of the equation, which is f of x in here. So yp equals f of x, but you will not have it as the same form as the f of x in here. In fact, there is a table that helps you to choose the general form for your particular solution based on your main equation. So this is the table, as you can see. So you can see here, when you have f of x, you have y particular of x. If you have your right hand side of the equation in the form of a multiplied by e to the power of cx, then you have that will be r multiplied by e to the power of cx. If you have cosine or sine, or a function multiplied by e, a function multiplied by cosine, a sine, etc., all have general forms. You can use the general forms as we will explain shortly. Okay, so you got your form. Let's say here the f of x, just for the sake of explanation, equals e to the power of x. In this case here, the y of p will equal, let's say, a multiplied by e to the power of x. That's what it is. Then you will find the first derivative of that term, which can be again a multiplied by e to the power of x. Then you find the second derivative of your particular solution, which will be e multiplied by a to the power of x. Then you substitute these in equation number 1. So you have here the y double prime, just put in here whatever term you found, y prime, and the y, and from that you can find the value of the parameter a. It will equal a certain value. When you have that, substitute the value of a in your y of p, y of p equals a multiplied by e to the power of x. Let's say here the value was 2, so your particular solution will be 2 multiplied by e to the power of x, and so on. Now your final solution, y will equal whatever the y homogeneous was, plus your y particular, which is 2 multiplied by e to the power of x. As simple as that. Solution could be long or short, but it will be depending on this form of solution. Just follow the steps and you will solve it. Either big or small equation, you will be able to solve it with a little bit of focus and training. Okay, as usual, let's take an example that will help us exercise what we learned. So we have in here y double prime minus 6y prime plus 9y equal 5 multiplied by e to the power of 3x. Okay, before we start, remember when you have your homogeneous solution, it will be a certain value, let's say e to the power of x. Now in your particular solution, when you go back to the table that we mentioned earlier, if you want to represent the particular solution based on the right hand side of the equation, let's say a multiplied by e to the power of x, but these two are identical, it's a good practice to, in this case, to add or multiply that equation by x. So you multiply by x, and if the homogeneous solution have an x, then you would multiply, this is a multiplication, multiply by x squared, so that you will differentiate between the y homogeneous and y particular. In the same time, you will still have the same final answer that will solve the equation. Okay, let's start here with y homogeneous. We have y double prime minus 6y prime plus 9y equals 0. Let's write it down actually. Y double prime minus 6y prime plus 9y equals 0. I prefer to use the exponential guess method. It's just closer to me, to my heart, whatever you consider it. You can easily say lambda squared minus 6 multiplied by lambda plus 9 equals 0. Go to your calculator or try to solve it on paper. You can find that lambda 1 and 2, this case is repeated roots case, if you remember, equals 3. Repeated roots case. Now you can say your homogeneous solution equals C1 multiplied by e to the power of 3x plus C2 multiplied by e, actually multiplied by x multiplied by e to the power of 3x. So this is our homogeneous solution. That's 50% of the problem solved. Now for y particular, we know that in here, let's mark it for you. In here, this is what you look for when you start to solve the particular solution. When you start to solve the particular part of the equation. Now, if you go back to the table, if you have 5 multiplied by e to the power 3x, you can say a, just any constant, a, b, c, whatever you prefer, a multiplied by e to the power of 3x. But as we said in our hint over here, that the particular and the homogeneous or let's say the right hand side of the equation, highly preferably not to be the homogeneous solution and your particular representation, they should be different. In this case, they are not different. You can see here the first term is e to the power 3x, which is exactly same as here. Second term is x to the multiplied by e to the power 3x. So we need here to have multiplied by x squared so that our solution will be differentiated than our homogeneous equation. Okay, directly we will do the second derivative so that we will be able to compensate back here. First derivative, and we already have the y. So let's do y prime particular. That will give us 3a x squared e to the power of 3x. That's plus 2 multiplied by a multiplied by x e to the power of 3x. Okay, how about y double prime? Y double prime of p equals 9a x squared e to the power of 3x plus 6a x e to the power of 3x plus 2 multiplied by 3, which will be 6 in this case, a x e to the power of 3x plus 2a multiplied by e to the power of 3x. Now that's equation number 1. Put these values back on the left hand side of that equation, equalize it with the right hand side, and try to find the value of a. In this case, if you do the math, the value of a will end up to be equals 5 over 2. From that we can say our particular solution equals 5 over 2 multiplied by x squared multiplied by e to the power of 3x. That's our reference. That's where I was looking for. So that's our particular solution for the equation. So now we can confidently say the grand solution for this equation is consisting of y homogeneous plus y particular. Y homogeneous, as we can see, equals c multiplied by e to the power of 3x plus c2x multiplied by e to the power of 3x plus the y particular, which in this case 5 over 2 multiplied by x squared multiplied by e to the power of 3x, and that's your grand solution for the non-homogeneous equation that we explained earlier using the undetermined coefficient method.